Hello everyone, this is Raja from MindCraft. Today we'll be having a session on Introduction to ICP. So let's start. Our agenda would be ICP introduction, overview of Kubernetes, Docker and related technologies, differentiation from legacy virtualization technologies, how does it relate with ICP, how ICP can be used on your infrastructure. Cloud computing. Cloud computing is a new technology often referred as simply as cloud. It is an on-demand delivery of computing service like servers, storage, database, networking, integration, software, and more. Main characteristics of cloud computing are elasticity, metered service, and self-service. Elasticity is based on a business demand. You can scale up and scale down your resources. Meter services, it focuses on OPEX costing model for actual consumption, that is pay per use. Self-service, all your resources, IT services can be deployed and can be self-provisioned. ICP. ICP is nothing but a cloud platform offering from IBM for developing and running workloads locally. It is used to design, develop, deploy, and manage on-premises containerized cloud application which resides behind your firewall. It includes container orchestrator like Kubernetes, a private image repository, a management console, and monitoring framework. It is built on open standards which includes Docker, Kubernetes, Helm, and Terraform. ICP has got some core components like master node, worker node, proxy node, a dashboard, and there's one more component called boot node. Boot node is a bootstrap node which is used for running installation, configuration, node scaling, and cluster updates. Master node, it is where the management console resides and the Kubernetes components resides. Worker node, this is where your actual workload is executed or run. Proxy nodes, this is used to provide external interface service for incoming traffic to connect to your cloud and its applications. Kubernetes. Kubernetes, commonly referred as K8, is used for automating deployment and scaling and managing containerized application. It is part of CNCF project, that is Cloud Native Computing Foundation project. Kubernetes is now part of CNCF and is becoming a de facto standard in cloud orchestration. Docker. Docker is a platform for developer and sysadmin to develop, deploy, and run applications with containers. Docker provides another layer of abstraction, automation of operating system level virtualization on Windows and Linux. Initial stages of containerizations were designed for stateless applications. As technology advanced, containerization has become a stateful, that is, data persists even after the container is stopped or removed. Other containerization platforms like VMware, OpenStack, along with Kubernetes and Docker Swarm, they are enablers of cloud computing platform, which provides provisioning, orchestration, and management. Differentiation of legacy virtualization technologies vis-a-vis containerization. Containers are basically an open source technology that lets an application packaged with everything it needs to run in any environment. Container offers flexibility, versatility, and it has much smaller footprint and cost. Whereas a virtual management environment, virtual machines, which runs a full-blown guest operating system with virtual access to host resources through a hypervisor. In general, VMs provide an environment with more resources than most application needs. Being a lightweight nature of container, it becomes an ideal choice for getting applications to private or public cloud and for lending greater agility. How does it relate to ICP? ICP, previously called as IBM Spectrum Conductor for Containers, is a Kubernetes-based container management stack for running container workloads on premises. It's powered by Kubernetes, Docker, Cloud Foundry, and IBM Cloud itself an application platform for developing, managing on-premises containerized applications. It do offer DevOps and cloud automation capabilities to deploy, manage, monitor, and run applications. It is an integrated environment for managing containers that includes its own private repository and a management console and a management framework. ICP can be used in your infrastructure for live application scalings, load testing, deployment of containerized applications. When I mean live applications, it can scale according to your business needs. Typically, any live application will be having a month-end or year-end spikes, typically during batch loadings, load testing scenarios, wherein an application needs to be load tested. So for load testing, you can scale up and down based on your requirement, such as CPU, memory, and other resources. Can be used for deployment of containerized application. You can develop containerized apps and deploy it and run it on ICP. Last, ease of use. Doesn't require any scripting knowledge. It's a point and click. Now we will proceed to a small demo session. We'll provide a demo on provisioning of a web server Nginx in ICP cloud environment. This is an ICP console where we will log in. This is the home page. We will start creating a namespace like environment, and then we will proceed with the deployment of a service named Nginx web server. This is where we are creating a Nginx deployment plan. Nginx is a web server service. Here we see the service has been created, deployed. The service has been deployed and started. Now we will proceed to create a cluster service. The cluster service component is created. Next step would be to create a node service. Once it is done, our web server would be up and running. Here we go, the home page of our Nginx servers. This shows our web server is up and running. Next step would be, we'll be showing you an auto scaling feature, part of our IBM Cloud. Auto scaling is something where we define a threshold policy. Based on the policy, if specific load is reached, ICP will create multiple replicas. Here we decide the minimum replication which is required and the maximum replication once the threshold is breached. So our auto scale facility is configured. So minimum replica it will be 1, max replica is 3. So now we will proceed to generate a load on our web server. Before we generate, we will check whether the web server page is coming or not. Yes, it's working fine. We'll proceed to generate a dummy load on our web server. This is a small script called created using while loop. We'll put random continuous request to the web server. We are duplicating the multiple requests so that enough load gets generated. Based on that, we will show you how the auto scaling happens. So we will wait for some time to so that load gets generated. We will go back to our ICP console. We will see the scaling part. We will generate few more load. It will take some time, couple of minutes to have the load on the server so that it can reflect on ICP console. So it's increasing slowly. Previously we saw the CPU utilization as 6%, now it has gone to 8%. Our threshold being 10%, so it will take some time. Let's see what is the status now. So let's open a few more consoles and we will put some more load to make it fast. Let's see whether it has increased or not. So let's wait for a few more minutes. So we have reached target utilization. Now let's see how the policy works after scaling. So we have to wait for a couple of more minutes as it has to cross the threshold value of 10%. Let's see. It purely depends on a lot of factors like the CPU utilization, memory utilizations, and the average load at that point in time. Let's wait more, a couple of minutes. Let's see. Yes, if you see that initially our Nginx server had the initial value of 1 of the replicas, now it has reached 2. So this is how auto scaling works. So that's all about auto scaling. So now we move on to our QA session.